In this example, we want to look at the limit as xy goes to 0, 0 of x squared minus y squared over x squared plus y squared. Okay, so let's look at C1. So C1 will be the path as x goes to 0 while holding y constant at 0. Okay, so let's take the limit as x goes to 0, y is fixed at 0, and that's just equal to, plugging in our y equals 0, it's equal to the limit as x goes to 0 of x squared over x squared. And the reason for that is that y equals 0. We fixed that, and so we just plugged in 0 for the y squared. Well, this all simplifies. If we cancel out here, this just simplifies to a big 1, and the limit as x goes to 0 of the constant 1 is just 1. Now let's look at a different path. So now let's look at the path given by C2. So we'll say C2 is the path as y trends towards 0, holding x constant at 0. In other words, we're looking at the limit as x, y go to 0, 0, but x is 0. So 0y goes to 0, 0 of x squared minus y squared all over x squared plus y squared. Plugging in x equals 0, we have the limit as y goes to 0 of negative y squared over y squared, and canceling there we just get a negative 1, and the limit of this constant negative 1 is negative 1. And since these limits do not exist, we say that this original limit up here does not exist. Right? For that limit to exist, it would need to be independent of the path we approach 0, 0. And we can see we get different limits depending on the path we take towards the origin. And that makes perfect sense when we look at the picture of this function. So this was the graph of our function, and we can see that if we come in here on the trajectory where y equals 0, so y equals 0 will be coming in here, and the limit of our z coordinate there, that is 1. And we saw that algebraically. And then the other analysis we did was along path C2, and that was the case when x is 0. Right, so that's like right here. If we come in along that valley, we let y approach 0, we can see that our z coordinate is way down low. It's about negative 1, and indeed algebraically it was negative 1. So the limit does not exist in this case. Okay, let's do a different example. So in this example, let's compute the following limit, and we're going to look at it along 3 different paths. Now you may want to pause the video here and try it yourself, and then come back and see if we agree on our results. Okay, so let's look at path C1, and this is going to be the path as y approaches 0, holding x equals 0 constant. So this is the limit. 0's for x, y goes to 0, 0 of xy over x squared plus y squared. Okay, so what do we have? We have x is 0, so this is going to be the limit as y goes to 0. Plugging in x equals 0, we just have 0 in the numerator over y squared, and 0 over anything is 0. So that limit is equal to 0. Next, let's look at the path, different path. I'll call this C2. This is the path as x goes to 0, as y equals 0 is held constant. And this is going to look like the limit of x comma 0 trending towards 0, 0 of xy over x squared plus y squared. And once again, we find that this limit is going to be 0. Right? Plugging in y equals 0, we get 0 over x squared. That's just all 0. So far, so good. It looks like the limit, if we come in on those 2 paths, is going to be the same thing. But we have one more piece of analysis here, and this is the path along the line y equals x, or x equals y. So let's take a look at that. I'll call that path C3. And this is the path x equals y as x and y both approach 0. Okay, let's take a look at what we've got. So I'm going to write down the problem in a little bit more detail because this one is a little bit more involved. So our original problem said the following, and that's going to be equal to, let's see, y is equal to x, so we can substitute all those values in. Let's do that. So this is just going to be the limit as x goes to 0, in the numerator x squared, and in the denominator x squared plus x squared. Let's see, that's x squared over 2x squared, so that cancels to be a 1/2. And the limit as x goes to 0 of a constant 1/2 turns out to be just 1/2. So what do we conclude? We can conclude that the limit as y goes to 0, 0 of xy over x squared plus y squared does not exist. If we come in along certain paths like C1 and C2, we get the same value, but we come in on a different path, we get 1/2.